So this is chapter 4, Rust error handling, from this wonderful book, Rust for Rustaceans. So before jumping into the actual chapter, just a little bit about me. So I'm Kavi. I live in Netherlands. I'm an engineer at Grafana Labs. One of the maintainers of Grafana Loki OSS. Doesn't matter if you don't know what that means. It's something to do with the database and logs. Speaking of Grafana Loki, so my background is mainly databases and distributed systems. And I like Rust. I love Rust actually. Otherwise, why would I be here, right? So, and also I just want to show off. I own the copy of Rust for Stations signed by Jon. I got it from last year EU Rust conference. So yeah, let's get started. So this is very short chapter, like 6-7 pages, I guess. So yeah, before preparing a presentation, that's what I thought, how hard can it be? But I was wrong. So yeah, so even though it's a very short chapter, I personally learned a lot in going through this chapter. Particularly, there are a lot of subtle things which Jan pointed out, and in different cases. So I hope like everyone will enjoy this chapter as well. So the general agenda here is at the very high level, we're going to discuss a couple of things. One is how do we represent errors whenever anything fails in a Rust code, and what are the different use cases and what are the different types of those errors we care about. And the second one is, okay, you have error now, how do you propagate this error? So usually you call different methods, different functions from different grades, and they may have their own custom errors. And how do we chain all those things like without any pain, basically, right? So that's what this propagating of error means. So yeah, let's start with representing errors. So what Jan kind of like starts the chapter is like, so anytime you write a code in Rust that fails, you should ask yourself an important question, which is basically how the users who actually calling this or using this code will interact with the errors returned by your code, right? So that's important questions, which which kind of like decides how you should represent the errors that you're going to return to this user, right? So you can answer that question in two ways. One is you tell the user exactly what happened with all the details you can provide to the user and different types of errors. Let's say it happened, this specific error happened at this due to this cause, maybe something like that, right? And the second way is to just tell the user something bad happened so that the user can just log it and move on, right? So depends on what you choose. It directly impacts how the user is gonna handle the error received by them, right? By calling your API or your methods or whatever it is. So yeah, depending on your answer here, depending on what you choose, there are two types of categories here. One is enumerate error, which kind of like you tell the user, okay, these are all the possible error can happen when you use this piece of code, when you call this particular function, and these are the possible error types or error. And the other way is like you just tell something bad happened, right? Via some simple, what you want to call it as opaque error. So which can be like a concrete type, but it doesn't tell about much about different types of errors, or it doesn't give user the control to choose to differentiate between what happened. We'll see exactly why this is the case, why we need to think differently when we want to handle it in these two different cases. So first we'll start with enumeration. So which is where you provide the user all the information you have, right? Like different types of error, and they have more control in a way. They can choose what to do and how to introspect these errors, and they can make a decision based on it. So one small example to understand enumeration error is, let's say you have some web server that is just copying some input stream into output stream, right? So here, this copy can fail, of course, and it can be completely possible, like one of the stream has failed. And but if that does, so what do you tell the user, basically, right? So do you tell what stream caused this failure? And why does this matter? Why we need to differentiate this error? Because input stream can be failed for multiple reasons, right? One could be, let's say, the server or the machine where this code is running. Maybe there is a disk failure or disk is ejected, for example. So that's the reason the input stream can be failing. And the output stream, which is usually some kind of network connection you're writing to respond to the user, so the client would have just disconnected, right? So so depends on what type of error the user have. When I say user, like whoever calls this API, right? Like whoever calls this copy method, basically. So they would have some control to handle the situation, right? So they can do different action based on the error you return. So for example, if it's just a client disconnect, then basically they can ignore. And if it's maybe like if it's some problem with the disk, then there is no point of running any more requests, right? Because everything's going to fail. So basically you may have to shut down the whole server. So that's the idea why we need to have different enumeration of errors. So in our case, for this example, we may have something like copy error, which exactly tells where the error happened, whether it's from the input stream or output stream. And even like if it's input stream, we also wrap the underlying error right here, like IO error. So which basically the goal here is to, like I previously said, to give as much information possible to the user, which also includes the underlying IO error, right? So yeah, this is what it looks like. Let's say if you want to enumerate error for our copy API. So in addition to just creating the error type, like copy error, so we may also have to implement few traits and make sure we have a static lifetime whenever possible. And now we'll see why this matters and why this is important to make sure your error, in this case, copy error, play nicely with the rest of the ecosystem, right? It can be like other crates who is calling your API, or yeah, so it can be like any method, or it can be any functions from different grades who is calling your API, and they has to, and all those API can have different error types, their own custom errors. So in order to play nice with all those errors, you may have to do this extra steps, which Jan claims it's worthwhile. So first is implementing error trait, STD error trait. So why we should do it? Basically because this trait has some methods which is useful for introspecting the underlying error, right? So the interesting thing is the source method. So the source method is basically, so in our case, we have this copy error in underlying with the network error, right? So we can wrap this copy error into some other type. We can just build all these chains, right? So how this source is useful is like the user can print, or like they can get to the bottom of the complete backtrack, right? So what exactly happened till they find the root cause. So one example is what I shown here, right? So let's say your API call to read this file is failing. You're trying to parse something from this file. So this error clearly says what exactly went wrong, right? So now you can have a bit of a control, right? So you know exactly what happened, and you can go fix it, or yeah, you can mark it as this like invalid file or something. So which is basically like telling the user what exactly happened with all the information you have, which is good, right? So how does it look like for our copy error? Should be straightforward. So like I said, we have our own like a wrapper, which is like an underlying error, like a network IO error, right? So whenever someone calls source on our copy error, we just return the underlying source of the error, basically. So which can be a disk failure or client disconnected, whatever it is. So the other one is display and debug trait, right? So why should we implement this traits for our error? Because it lets you to print the error meaningfully, right? So if it's so ideally when you're implementing the display trait, so you should respond like a single line explaining like a short description what went wrong. And yeah, Jan kind of like argues it should be following certain standard, like everything should be lowercase and without any punctuation. Why? Because so always imagine like your API will be a part of a bigger system, right? So so like basically it will be nice that your error message integrate well with other bigger reports of errors. And the other thing is display and debug is one of the constraint if you want to implement error trait. So basically what that means is you cannot implement error trait without implementing display and debug. And the debug trait is for more descriptive. Let's say if your customer has any details like port numbers, request ID, file path, where it failed, it should be visible in the debug. And usually just deriving the debug trait should be good enough. And if you're reading some old Rust code, so you may see this error description method, which is kind of like deprecated in the favor of display trait. So just a small note. All right. So that's display and debug. So send and sync. So why do we have to implement this traits? Because it's good default to make your error, in our case, copy error, to be like thread safe, right? Why? Because we can pass it around anywhere we want without worrying about thread boundaries. And there are also like some error types from standard library, for example, IO error also implement send and sync. So let's say when you wrap these errors in your type, and if your type doesn't implement this send and sync, then it's kind of like make your life a bit harder to pass around this error. So, I mean, having said that, it can be completely possible your error can be not thread safe, which is completely fine, but it should be like deliberate. It should you should make sure whenever it's possible you should implement send and sync, and which kind of like gives you a so you have to be like a bit careful before adding this RC or ref cell types into your error type, because these types by default make your what are the type in this case error non-thread safe, right? So that's something to be taken into account. So all these things, this traits, we are doing it because it should fit well with the rest of the ecosystem. That's the goal. And finally, to play nice, make sure it has a static lifetime if possible. Again, I mean, that can be a legit case where it cannot be done, but yeah, it should be like a default consideration to make sure your error type has a static lifetime. So this is, so when we talk about error propagation, next we'll see why this is helpful, because like I said, like you may be using different APIs from different traits, which each one has different error types. So if you have a static, then you don't have to worry about propagating this error up the call stack without worrying about lifetime issues. That's the goal. All right, so that's enumeration. So where you can have different types of errors. Each one can have as many details it wants, and return the user so that user can take some action, have some more control and take some action depends on what type of error, right? That's the enumeration. And the second type is opaque error. So now imagine a case where you are basically like image decoding library, right? So on the whenever that one fails, still user may want to know why it failed, but so why it failed can be a different reasons, right? So let's say, for example, there can be some invalid field in a header, like a size field or whatever it is, that can be invalid, or the compression algorithm is failing for some reason in a specific block. So all these are legit reason, but even if you tell this reason, even if you communicate this reason to the user, when I say user here, again, it's who calling your API. So they have very less control to take any meaningful action, right? So even, let's say, even if you tell them, okay, the compression in this specific block is failed, they cannot do anything meaningfully to recover the application at this point in time, right? So that's the reason where the opaque errors can help. So here, all you need to do is just tell them something failed and then pass them like a single error type. Can be concrete, but yeah, just convey that this thing failed and you cannot do much anything about it, basically. So when we talk about opaque errors, there are certain advantages, like if this is your use case, like image decoding, and you can work. So the public API exposes just one error type, right? One opaque error type, which kind of like makes your crate or library easy to use from the user point of view. So they don't have to worry about handling different error types, right? So that's one advantage. And similar to enumerate error type, we should also consider implementing all these traits, which we talked about a bit earlier, just to again, like, yeah, play nicely with the different REST ecosystem. So of course, this doesn't mean you cannot use any internal error types, different error states. You can, of course, but you have to be careful not to expose them to the public API. So which just makes the whoever calls your API has to, yeah, they basically have to deal with different errors, which they don't want to in this case of image decoding example, right? So that's opaque error. So how does it look like? So it's more of a theory, right? It's what we talked about. So, okay, you expose it as a single error type, but how does it look like exactly? So it can be like a single type, concrete type with all the private fields, exposing only some methods, which for displaying or to know some cause of it, to introspect the error. Or it can be like completely like type erased error. So that's what Jon calls it, this signature, like just a box of error trait along with different traits, just implementation of different traits, right? It doesn't matter what the concrete type of the error is. So if your API has a return type of this error, type erased error, then yeah, it's opaque error basically. So the user cannot do much, anything other than just knowing it's an error and then just print it out or log it maybe. So that's basically what they can do, nothing much. So so let's say if you are exposing it as a concrete type, so still you can add some information, like if you want to provide like image, if let's say if it's a image decoding, like image name that is failed, or yeah, some kind of errors code maybe. But yeah, but just to remember, like no matter like you we are giving opaque error for the reason like user have very less control. They cannot do any meaningful recovery, even if they know the error happened. That's where the opaque error comes in. So usually when we do this type erased kind of error from our API, so we put it inside the box or org. The reason being, given like error happens less compared to the happy path usually. So let's say you pack it in the result, right? So it shouldn't add much overhead to the result type itself. So that's why it's like a box. So it's just like a pointer without the actual full size of the type. So yeah, that's something to take care. What else? So yeah, so another advantage of using this type erased signature in your return type is basically, so yeah, because it says nothing about the error itself, it's easy to propagate. So with the Koshimaka operator, right? We will see a bit about it when we talk about propagation, but yeah, that's one of the advantage of using the type erased error as well. So yeah, so the static lifetime here is also important. As we already seen in the enumeration, right? So static helps to avoid any complexities with worrying about lifetime issues. So there is also another thing, which is a bigger purpose, which is downcasting. So what that means? So generally downcasting means converting one type into another one, into a more specific type, right? Let's say you have just some trait object, and you want to know what concrete type it belongs to. That's the general downcasting, what it means. In case of errors, what it means is like, let's say you have some DIN error, and then you want to downcast into specific concrete type so that we can take some action, right? So here that is an example. So basically you get some DIN error, and then you are downcasting to see if it's a IO error, right? So this is, I mean, this is not that common, but if you want, I mean, if you want to provide your user of API this compatibility, then you have to make sure your error has a static lifetime. Why? Because yeah, the downcast ref takes the argument with only the static lifetime. So if your error doesn't have static lifetime, then you can't, your user cannot use downcast ref method on it. That's another advantage of making sure your error type has a static lifetime. All right, so here is a question. Speaking of opaque type erased errors, right? So let's say you have an API called foo, and it exposes the opaque error. Here it's box DIN error, right? It doesn't say anything about the type, just like just an opaque type. But internally, you just return a concrete error, like my error, for example, right? So here is a question Jan asked. Let's say in future, you change this my error to something else, my custom error or something. So does this mean you break the API or no? So why thinking about this is important? Because imagine your user used downcasting and try to map it with my error, right? So they got this error, they downcasted and check if it's a my error type, and then they make some action on top of it. Depends on whether it's a my error. Now it's not returning my error, now it's returning something else like my custom error or something. Now, even though the API signature doesn't change, but the code written by your user kind of like behaves differently, right? So this is still, so what Jan argues is still it's under debate. Yeah, Jan, okay, his personal opinion is it's not breaking a change, because there is a reason why we're exposing it as an opaque error, so that we have more control to change this underlying error types. So yeah, just another note here is, even though the box DIN error looks like it's a type of error, so the whole type itself, the box of the type, doesn't implement the error trait itself. So it's up to you to make sure to implement the error trait. Why? Because again, it boils down to play nice, right? Because your error should implement error trait so that it can be propagated, it can be worked with the question mark operator, it can be introspected, it can be printed fine, so all those sorts of things. All right, so yeah, this is something I also didn't understand fully, but I just put it for the completion's sake. So what Jan argues is like, so the downcast ref method is something which trying to interpret the actual type, the underlying type of the error at the runtime, right? So how is it safe, basically? So how does it even know to find or even to check whether the given DIN error, which is a dynamic type, is this particular type T of concrete type, right? How does it even knows? How does it finds out, and how does it safe? So the long story short here is, it uses two different traits. One is standard any trait and standard type ID trait. So see, I looked into the code to understand a bit better, but still I'm a bit confused how this exactly fits into the picture. So the TLDR here is like this type ID interface, and this type, sorry, the type ID trait is something being implemented for every single type, which is a unique identifier. Let's say if you're using my error, or if you're using like int, or if you're using like my int, every single type will have some unique identifier. So then the error trait has this hidden method. It's not exposed. It's not like source method that can be called by anyone. So it's like a hidden method, type ID, which kind of like gets this unique identifier, right, for the any type that is passed into it. So what the downcast ref will do is we'll call this method type ID internally to get this type ID and then try to compare with the to type. In our case, it can be the concrete type actually implemented it. Let's say, yeah, my error or something. And then the other one is like the one you want to downcast to can be like IO error or something. So each one will have two different type ID, and just by checking this type ID, this method can tell you, yeah, whether it can successfully downcast into the proper type. If it's the same, it can confidently like change the reference, like cast the one reference to another because the type ID matches. Else, it just returns none because the downcast ref returns option. And yeah, if it's none, the type cannot be converted. So that's how it works under the hood. All right. So okay, just give me a sec. Just put some lights. Sorry. Cool. So this is the last one in the representing errors, which is so far we have seen two types, right? Like enumerating, which is giving a user control of exactly what type of error you can get out of the API. Other one is opaque error, which is just a single opaque error, which just tells the user something went wrong. The third one is a special error cases, which is there are some exceptions to, oops, sorry, yeah. So there are cases where some functions or methods cannot return any meaningful error, right? So in that case, it can return just a unit type. And there can be cases where some method is running continuously, like a loop, maybe like some HTTP handler waiting for service or like waiting for connections kind of thing. And there can be some methods which which never have to return any error because it cannot fail, but still has to return the result because to match some trait in the function signature, right? That can be totally possible. So how do you handle these cases? And finally, there is this one special error part of a result from a thread in a standard library, which kind of like, so if you pay close attention, the box, it says like box din any, not din error usually. So why is that the case? So that's what we're gonna see now. So case by case. So first thing, what if the functional method cannot return any meaningful error, right? So it's conventional to use result with in the place of error, we use just unit type, right? Just to denote there is no meaningful error you can expect from the API. But what Jon also argues is like it can be tempting to use option instead of result t comma unit type, because functionally if error happens, you can return none basically, right? But he argues it's anti-pattern. The rationale being, so the error means something bad happened, right? Which means the client or the user of the API can retry or report it or log it or handle in a different way, like exceptionally. But whereas if you change that to option and return none in those cases, it doesn't tell you like something bad happened. It just tells like function has nothing to return, right? So both are like conceptually different. So you shouldn't use option when you want to in this particular case. And the other thing is like result has this must use annotation. So what that means is whenever you get whenever you get a result out of any API, your compiler enforces you to handle all the cases like OK and error, right? Otherwise, it just keep enforcing you. Whereas it doesn't happen with the option. So even if you don't care, even if you don't handle the none case, it's just not going to comply. So which is probably you will miss error handling, right? Another subtlety here is the unit type doesn't implement error trait, but you have to implement error trait for all the reason we discussed before to play nice. Yeah, that's something to keep in mind. The second case is what if your functional method run continuously in a loop, right? Or you for sure your method may not return. For example, there is a panic case or maybe like some exit function inside it, right? So how do you represent in Rust type system is Rust has this never type, which is represented by just an exclamation. So what that means is like whenever you use this exclamation in place with any type, so Rust kind of like understands this particular type can never be generated. So why this is important to make it explicit? Because of course the compiler can do all sort of optimization, right? So let's say when your API is returning a result T, but instead of error it returns like this never type. So then what Rust will do is then, since the error cannot be generated, which means every time you call unwrap on this result, you cannot, there cannot be error, right? So it doesn't even need to have generate the code to handle the panic whenever anyone calls unwrap, right? Which is kind of like neat. And other advantages, like let's say you use any pattern match, and one of the pattern is like this exclamation. So then those variants need not be like handled, not be listed in the match handler, right? So yeah, that's also neat. So yeah, that's why it's important to make it explicit when your API, when your method or function never returns an error, basically. So some example for never return type, let's say as a loop forever, right? So this function can never be returned. So we just mark it as never type. And then again, like if it panics, it's not going to return to the client whoever called this function. So again, mark it as never type. And yeah, the third function is, I mean, I have one question, maybe we can discuss later. I cannot make it work with the stable Rust for some reason. Maybe I think it keep complaining the exclamation is unstable yet. So I couldn't call this from main. I couldn't actually make it work the way I wanted. But theoretically speaking, like, yeah, so whenever you match this always okay, you don't have to handle the error case, because for sure the error cannot be produced because of the never return time. All right, which seemed, yeah, personally, it's really nice idea, to be honest. So the another special case is the final one, which I mentioned before, is this weird type from the thread library, from the standard library, which is instead of din error, it says din any, right? And why is the case? Because this specific result or the specific error case can happen only during a panic, meaning like whenever you try to join two threads, which panics. And so whatever the argument passed to panic will be the argument passed, will be kept in this result, which can be literally anything. So usually we just pass some kind of format string to panic, but it can be anything. So that's why this result type, at least the error section of the result type, is din any instead of din error. So yeah, so Jon points out like you can see these kind of things in a standard library, and just to be aware the rationale behind it. All right, so we are done with the first section. How is everyone feeling? Yeah, it's not even though it's a short chapter, there are so many subtleties actually. So all right, so the final section is, okay, now we have error. Now we created error, depends on the use case, depends on what user wants, depends on how much control the user have. We represented the error, we created the error. Now how do we propagate it, right? So usually we propagate via the quotient operator. So which is basically a shorthand for you unwrap or return early, right? So in this example, for example, like the things set up, it can fail. And if it fails, it just returns error directly, or return early. Else it just proceeds. In this case, it just returns some legit value. So that's what the operator does, question mark operator. But there is a catch though. So in this case, let's say it's a function, do the thing, right? And inside the do the thing itself, it returns some error, my error type. And inside the function, you call thing setup, which is returning a setup error. So, but still you're using a question mark. So how does this operator kind of like handles this case, right? Because now you're returning a setup error, but your API is returning a my error. So how does it works basically? So the interesting thing is with from tried, right? So if you remember, one of the things we were discussing about how to play nice with the REST ecosystem is to implement this from, oh, sorry, not from one, that's different, sorry. So yeah, so how it works is basically the question mark operator can be happy as long in converting different type of errors, as long as one error type can be converted to other type via this from trait basically. So in this case, the error X can be converted into E because yeah, it implements from trait from T. So yeah, this is a small example to show you why this question mark works, because it has an implementation of from trait. Now we are good. So speaking of from and into traits, Jan argues, like put us note some of the historical perspective of these two traits. So you may be questioning, why do we need a two traits? Can we just move on with just one trait, either from or into? So there are a couple of reasons, at least what Jan says, is one is a historic, reason being before Rust 1.41, where the coherence rules been updated. So you cannot basically, we cannot do what we do now with a single trait because of the coherence rules. And that's why we added both the traits. And now after Rust 1.41, it's too late because it's already stable. So we cannot remove it. That's kind of like from the historic point of things. The other things he also encourages is like from the ergonomics point of things. For example, imagine these two cases, right? So which function signature would you prefer? For example, usually, so the first one seems legit, like function implement into foo, right, which is short and it conveys what it wants to convey. I would prefer the first one. And in the second example, like intent from, I would prefer again the first one. So here, as you can see, into and from, both are we using it, depends on our taste. And it usually, go with the one that looks ergonomics to you. So given these two traits, how do you pick? So simple rule of thumb, what Jan recommends is like, whenever you want to implement for the conversion, you just implement from, because I think there is a blanket implementation which also does into, I guess. But the into trait goes well with the bounds in your API as a return type or in arguments. So it's better to use into in the bounds basically of your types. Currently, the question mark operator uses from trait, like we saw how it converted from the setup error to the my error via from trait. So Jan argues like maybe in the future it can also use the into trait if there is one. But I think based on what he's saying, currently with the existing toolchain, it just uses the from trait for the conversion. All right, so how does this really question mark operator works here, right? So this is kind of like a bit of a future. That's why there is an asterisk there. So trait is not stabilized yet. So potentially the question mark operator is just a syntactic sugar for trait, right? So why? Because it gives like a nice opportunity here, because if we have a trait, which is kind of like a generic trait, which kind of like you used to communicate this idea, like for example, your type can be in any of the state, either it's needs a future computation, which is a happy path, or we have to stop and produce the error and return it basically. So these are the two cases where any type can satisfy this this behavior using a try trait. So as probably you guessed, so this is not only for the result, we can use it for option and also poll, because all these cases you find a similar behavior. So there is a happy path and there is a stop and just return early, right? Or produce error instead. So those behavior can be expressed using this single try call try. So why this is helpful? Because it makes a lot of handling a lot of happy path code easier with the question mark operator, right? So once it's stabilized, then yeah, we can use question mark operator in different places, even to handling the poll in when you're doing asynchronous model of programming. So yeah, so that's basically how the future of question mark operator looks like. But there's a problem with the existing question mark operator. Let's say this example, right? So again, do something. So here it's calling another method, thing setup, which can fail. And we do something with the thing. So if it fails, it returns early, right? But end of the function, there is also one step, which is thing.cleanup, which can never get executed if it returns early, right? So this is still a problem. So how we handle now is just, yeah, we just manually do some match statement or yeah, handle it manually so that this things.cleanup always runs, even in case of error. But there's a better way in the future, which is using a try block. So which is also not stabilized yet. So the idea here is like, so we introduce this try block, and then, so try block is kind of like a loop, except instead of returning, if there is an error, if it faces an error, it just breaks from the block, and it just continue running the remaining step unless, and then you can return the value of the block, which is R here, which can be the output of evaluating the try block. So this is one of the way. I mean, this is again like not stabilized, so syntax can change. Maybe like semantics also can change. That's what Jan says. Maybe, but the more or less the consensus with the community is it will get merged soon, right? As is like you see here. So yeah, that's yeah. I find it's really exciting, the try blocks. So yeah, we have reached conclusion. So to summarize. So always, whenever you write a Rust code that can fail, ask yourself a question. So whenever your user or anyone who calls this API that can fail, how the user is gonna interact with the errors that you're planning to return. That's the important question you should ask yourself. Depends on the answer, you can construct those errors in two different ways. Mainly, of course, there are some special cases like we saw before. So usually it's either enumerate, meaning you just put down an exhaustive list of all possible errors and the user can get back, or you can just get around with a single opaque type. And then we saw the so once we have the error in place, how do we propagate the error? So it's generally using the question mark operator. And we also discussed how some of the future improvements like a try trait can make it available to use this operator in a lot of other places in handling the happy path more nicely. And we also saw one of the existing problem with the operator and how, again, the try blocks, maybe in the future, once it's stabilized, can solve that error nicely. So yeah, that's pretty much it. Thanks for listening. Go for it if you have any questions.
Awesome talk. Yeah, if folks want to just unmute themselves for questions, or yeah, or post it in the chat if you don't want to unmute yourself, that's also totally fine. So far, just lots of congratulations. Yeah, excellent presentation. On like you're saying, like just before, it looks short, this chapter, but there's so much stuff.
So true. Because yeah, I mean, we were discussing before, but yeah, I'm saying it here because this chapter is, I personally find it like really very, very interesting, because usually when you read a book, when you explain a concept, they give an example and you don't have to leave the book basically, right? Till you complete the chapter. Basically, all you need is a book and like some terminal or like somewhere you can run this code. But here you need to like open a browser, just go research, do all the research with what feature is stable, what unfeatured is stable, and what macros you use to use this feature, all those sort of things. And you also get to introspect like some of the internal like error trait and how this downcasting happens. So yeah, it's really like very interesting chapter, to be honest, even though it's like 6-7 pages.
I will add one thing. I don't know why it wasn't mentioned in the book, because the book is all about pure Rust on the standard library. But I just use the this error and an anyhow crate. So this error is used for generating the enums and implementing the error trait for you and doing all the conversions. And anyhow, it allows you to just like is that box din error thing that you can just use everywhere. So if you're feeling lazy, I highly recommend those crates.
Yeah, 100%. Yeah. I think even in the first page of this chapter, he mentions the error handling in Rust is a bit more debatable at this point in time. No one settled on like single approach, so that's why he didn't recommend any external traits. But yeah, 100% agree. So even there is this blog post which is like a modular error, something like that. If you search for modular error Rust, I think that's a wonderful blog post explains how error handling in general. And also there is another blog post like this error and then anyhow error, which also tells like what Matt was saying. So all this opaque error, which is like very big to type. And so these crates provide some kind of existing types, which also implements all this nice traits already. So you just have to put the type and then the error propagation, all those chaining happens automatically, which is really, really cool.
Is that the blog you're talking about? I just linked something there.
Sorry, man.
I just linked a blog. I just wondered if that's,
okay.
That's the blog you're talking about.
Yes, looks like it. Yeah, that's the one. Yeah.
Cool. I'll read that later.
I'll add the link to the recording when we upload it. There's a little bit of chatter in about the the never return type, and yeah,
I have like a couple of questions, maybe because I couldn't make it work exactly. Maybe people can help here. Can I share?
It doesn't work. You can use the exclamation mark for like never returns in Rust, stable Rust right now, but to actually use it as an actual type, it's not stable. It's not implemented in stable Rust.
Yeah, I think the compiler compliance like it's unstable. I mean, that's okay, but I was curious about this. Where is this? This example, maybe not this one. So this example, the third one. So whenever I try to call this function, always okay. And my expectation is I don't want to put a match handler for error, right? So the compiler shouldn't bother me in handling the error case in the match handler, but still it was complaining for some reason. I don't know. Yeah, maybe I'm missing.
I think you still have to match, but the compiler optimizes it away. Is my maybe interpretation.
That's what I thought though. But then the book actually says you don't have to put it as a listing. That's pretty neat. That's what Jon kind of like says, I guess.
I missed that.
But yeah, maybe I'm pretty sure I'm missing something, but I just don't know what I'm showing.
See, the first two functions, they're possible in stable Rust.
Yeah.
Because the exclamation mark is not really a type, it's just syntax saying this never exits. So he says it's not meant to be combined with any other type like result or option or whatever, right? Or using generics.
Yeah, but what he says is when you pattern match, the compiler knows that any variant that contains the exclamation does not even need to be listed.
Was it Rust Analyzer that was complaining, or was it when you actually tried to do the build? Because
when I run cargo run, it just throws error. Basically.
Okay.
Yeah, that's
drop them an email and ask, or check the corrections in case.
Yeah. I mean, I'm pretty sure compiler is optimizing like even if you put the error case there. But that's why I don't know. Maybe he means differently. Yeah. Also, yeah, if I have any question, I have one more. Sorry, asking too many questions myself. So this example here. So one thing I don't understand here is, let's say this second line errors, right? So now whatever gets stored in thing may not make sense to call thing.cleanup.
I think this example is slightly misleading.
Yeah.
The example on the unstable Rust site, I think, is clearer, and that's to do with like combining multiple early returns into a single. Let me.
Yeah. So yeah, I think what you mean is inside this try block. I saw that example. I think you're pointing it out. So
thing setup returns a result of a thing, right? So thing ends up being a thing. So that means you can call thing.cleanup, because cleanup is a method on the thing type. Because the question mark also erases the result or option, right? So it extracts the inner type, and that's what's returned. So R will be a result type, because when the question mark normally it will return a result type. So that's why you can return it. But
yeah, I mean, returning R makes sense to me. I mean, also this whole block makes sense to me. Like, so this will hold the result of the try block. Like if you have multiple statements inside a try block, whatever that's failed early, it will just break it, and then that will be stored in R, I guess. So at least semantically. My question is, like, even let's take the example here, right? Even like without the try block here. So let's say something breaks here and then it returns. The problem, at least the problem, the Jan complains here is this never takes place. So if the cleanup has some resource cleanup, something like that, then it may never execute, which can cause some error. But my fundamental question here is, even if we solve this issue, the thing cannot be something the cleanup can be called on, right? When it fails.
There's code missing here. So that's the bit that Jan's worried about is the code that's commented out. So if there was some other operations in between that could fail, you need to know that you still need to call cleanup. So that's the crucial bit, is if you had some other operation that could fail, you still want to call cleanup. So obviously this is the classic thing where you would instead have like an RAI class or something where the cleanup gets called automatically. But here you for some reason can't have an RAI class. Maybe there's some additional data to pass in. So instead you explicitly call cleanup. But how do you still allow early returns?
Actually, I would implement the drop trait.
Well, yeah, exactly. But maybe there's some reason you can't. Like I can't think of one, but maybe there's some reason. Maybe you don't own the API, or maybe you're calling into like a C++ library or something, and you don't want to wrap it. I don't know.
Okay.
Like, who knows? But say there's some separate setup and cleanup states.
Okay, so now it makes sense, I think. Okay, so I mean, if this one fails, it's completely fine to return early. But let's say if one of this fails, then okay, I see the point. Okay.
Yeah, it's the code that you don't see that he's worried about.
Yeah, okay, now it makes sense. Yeah, thanks.
That's my interpretation anyway. I'm obviously.
Yeah, I mean that makes sense now, at least. Interesting. Okay. Yeah, this is kind of thing with this chapter, at least the whole book. Like you need to do some research. Like you can't just grab everything that chapter.
I wouldn't hold my breath on the try operator, based on history of the Rust language. I'm still waiting for the box keyword. That's been around for like a few years now. Like they're going to add the. I don't know whether it's cancelled or they're still thinking about it. It was going to be like a box operator you used to, which creates a box type. I saw somewhere lowercase box as an actual keyword. But I don't know. Don't know what happened to that. I think you can use it in nightly Rust.
But But what exactly it does though? So because if it's a block, so other than creating a box of something, or unless I miss something, like what exactly the use case the box is for?
It's just language support for a common idiom, I guess. Where you want to allocate something on a heap.
Sorry, just a brief aside. Kavi, apparently the slides aren't accessible currently, so you might change some setting on them. So
yeah, that's a good point.
It's fine. You can do it after, but just
it's fine.
I did wonder about the mechanics of question mark though before this talk, and I'm very glad it was covered. Like what exactly goes on under the hood? Why does question mark work? How can you? What does it actually do? What traits you need to implement? I'm sure that the information's there, but I never bothered to look it up. I just use the question mark all the time, and with this error, just things just work, or anyhow it just works.
Yeah.
Funny, I didn't even know about the try trait.
Yeah, I also didn't know. I just know like when I read this chapter.
We had a question in the chat. What is your preference, Kavi? Unique errors or errors with code locations?
Code location. Yeah, I think it depends. I know it's not a good answer, but I think what Jan points it out here is this interesting question, right? You should ask yourself. So if your error has this information, like the line number, is that what you're asking, or location? Maybe I didn't understand the question. Unique errors or errors with code location? Is it asking like opaque errors or opaque error with some extra information, or am I missing something here?
Opaque errors with extra information. I mean, technically, well, we can understand what unique errors are because it's simple. We can just think of them as like numeric codes, maybe. We can even serialize them in integers. Code locations is something that I found that people do it in, say, Leptos, because they bundle errors in a hash map, and errors are dynamically. So this hash map is dynamically created from.
And what do they do with that hash map actually? Is it like dumping it somewhere, logging it?
Yeah, I think they dump it in a WASM binary, and I've only started looking into it, so I don't know the details. But,
yeah, I mean,
they use STD panic location for computing the code location at compile time, and they so supposedly when an error is generated in the code, this STD panic location adds the like line number, the file name and line number, and
yeah, I didn't know about that one, but that's I mean that makes sense, because no matter what kind of error it is, it's good to know the line number of the error, I guess. So yeah, I think if you have that information, I think it's good. So I would say, yeah, I mean,
some projects are quite strict on uniqueness. So, but others are just never mind.
I mean, I can also think of cases where if you're running some CLI and then if something fails, yeah, I don't know. I mean, I'm trying to understand the use cases here of printing the location of the file here. I mean, it's definitely useful for the developers when you're debugging or something. But let's say you are using some CLI and something happens, some panics, and then it just prints the error. It's not much useful for me, but
you should use enumerations all the time for a few reasons. Number one, you should always give maximum information for human readable stuff. That's what the display trait is for. But also, you can use things like Serde to convert those errors into structured JSON or just pass through tracing and use structured logging for that kind of stuff. Generally, if you're producing errors, you should use enumerations, I think, in my opinion.
So for things like eBPF binaries, for example, in the Linux kernel. So if we write if we write an eBPF binary in Rust, there we can definitely define errors in enumerations.
And I think you should only use like something like the box din error for if you're consuming errors.
The question explicitly was to have line numbers versus unique errors, which I guess, maybe enumerations could solve if you use a unique enum at every calling point. But if you don't, and you reuse the same enum error in multiple places, then unless you attach some additional data, you're not going to know where that error exactly in the code was logged. The question as to who that's useful to, I guess server code is the classic example. It needs to be code that's in the developer's hands, because otherwise, once it's gone, you don't really have much control over it. But I don't really know what's considered how you would enforce a unique error around. So line numbers is often a good fallback, but quite ugly to. And then you got to match it with the version of your code that you've actually deployed. Otherwise, you're searching around anyway. I think probably most people just end up doing it on strings. They're like, nah, it's fairly unique. It's unique enough.
I think it's a good use for macros.
Yeah, exactly. Yeah. So, some of the tracing layers that you have available, like the one written by Luca Palmieri and Zero to Production, do provide the source code number and line numbers. You can get that out and how you choose to implement it. And yeah, the exact thing you would use is macros. But of course, that still relies on like where you're calling it, which might not actually be where you want to report the error. So it's like where matters to you, where's the important bit. Super interesting chapter. Any more questions before we talk about things we've got coming up?
Maybe just a statement. Like I was thinking a lot about this. Was Matt also was mentioning this error and anyhow, and I have the feeling that because sure we want to have as much information as possible, as long as possible, like with the enumerations, but as soon as you have really this bridge from programmers to actual users of the application, like providing this opaque type is quite powerful, I think, to not overwhelm the end user with error messages. And I'm thinking a lot about this because sometimes you have users that do like scripting, for example, right? They write like small equations and so on. My feeling is just like this way of like being explicit about everything is maybe a bit I think overuse is a too strong word, but it's better in like investigated than how can you really come up to a comprised version of the error, help your users.
One technique could be that a library produces all the information, because you never know how a library is going to be used. But the user of the library could convert the error from one type to another using the from trait, if they want to reduce the fluff, or like it's quite normal. Like when I write code to do graphics.
Think about like a framework for machine learning, where the user is really not like a programmer who goes really deep into the details. Then you also want to like come up with more Opaque types someday. I think that's a good use case.
I can give you a common example. Like when I'm doing working on a graphics engine, I use this error to do that. But essentially, what I can do is I produce my own set of errors, enums, but inside that, I link the original error from, say, WGPU. So I can do like a hash from macro using this error with a WGPU error. So, for example, when I'm setting up a window or a context, or a graphics context, I can take that information and embed it inside a much more simpler enum, which just says window creation failed. And they can act on window creation, ignore what's inside, if that's what they want to do. But if they wanted the actual error that WGPU failed, they can then get the internal error, call and run through display, and then you've got a human readable error. Or if you want, or you can use the source, follow the chain, and do a list of stuff which to the end user.
I understand this possibilities with converting from and into. I'm really what I really want to say is, like, probably when you're providing your library to users that are more programmers and are probably not too much interested in like solving internal errors, and this opaque type could be also useful. Like what comes to mind first was really this machine learning framework. So people could say, okay, I need like a descriptive error method, but I don't want to start to like now search for the right language model or stuff like that. Or
well, that's the purpose of debug versus display, right? Like debug is there for your programmer's error message, which is usually created automatically, and so you would have like a struct of all the error information inside an enum maybe, and then the display part is what you provide to the user, where you can and this error supports both, right?
Yeah.
So you can do the hash error above the enum with
but that's really like
that's his intended use.
Representation, right? I'm just saying, like, sometimes you don't want your library users, or your library users don't want to recover your errors. So then it would be an option to say, okay, I have an opaque error type here, because it simplifies your API too, right?
I don't
I
know.
think that's why Jon didn't kind of give hard and fast rules about specific things. There's general guidelines of, like, use the concrete ones for this case, but use the opaque ones for this case. But if you know who your users are, they're who matter. So you've got two use cases. Like, one is like information for yourself as a developer to figure out what happened, or information for other developers using your library. But if you're building an application or a library that's for a different client, then you need to think about, how are they going to be seeing it? How are they consuming these errors? Is it going to be just a wall of JSON, or is it going to be just a wall of information that's not useful? What is the key information I'm trying to extract here? And actually, error handling is hard. It's hard to do well, and it's something that you probably iterate on, where, like, there'll be certain cases where you'll be chaining together data, being like, well, I'm keeping all of the history of all of this error. And it's like, well, actually, do you need all of that? Is that actually a case where you need all the history, or is it one where you want to chop it off and just convert it to a really simple, that file wasn't there, or like the file was the wrong type or something? If you can simplify your error to actually give the information you wanted without all the metadata that isn't relevant to your user, then absolutely get rid of it. But sometimes
are we talking about two different things here? Data that's from the error that's going to be used by the program potentially, or just and displaying either through screen or log? Because I can see where you want to convert one to the other, but I hate libraries that don't give me everything, because it's up to me what data I need. Not like if I'm opening a file, I don't want just file not open error. I want to know the OS code or the failure, and all the information, right? So I can even the file name I used originally, perhaps, because I can take that error value somewhere else in my program and I can act upon it. I don't need to store the path name that I had when I called open, for example. So I personally prefer as much information as possible, and then I'll filter that for my use cases in the code that uses the library, rather than have the library decide for me. That's just my take on it. That's just my personal opinion. I'd rather have too much information than too little, really.
Yeah, I mean, I agree. Also, one thing just wanted to add is like if you're as a developer, for example, I think this point's already mentioned. So you may need to see everything, but imagine this example, what Jan was pointing out, like you are just passing a buffer of bytes, and then something happens in the buffer. So if it's a file, yeah, it's good to know the information where it is failing and the location and all those things. Let's say there is an API, you just pass like just a buffer, in memory buffer, and there is some error. So in this case, you don't have much control to fix it, right? So yeah, I think that's the point where, I mean, if you're a developer, for sure, even you may need some information. That's where the debug trait comes in, right? So
but I disagree with that, right? Because in that example, even though the program that's accessing the file can't fix anything, which is correct, I as a user can get that information, go back to the original file, use some other piece of software and fix it there, and then run my program again, right? So when you were saying that, I was like, no, that's not a good example. At least that's what I was thinking, right?
I think it boils really down to who's your user. Like if you're targeting developers who are writing Rust on their own, that's quite powerful. But a lot of users they are like doing software development to some degree, like in a kind of scripting, and for them it may be really beneficial to boil down their error code.
maybe I can ask
level.
this way. So can anyone like, I mean, I never used Rust in production per se, but can anyone like give example where you guys used opaque errors, like with a legit use case? Maybe some real-time example. I don't know.
Good question.
Definitely received opaque errors, I think.
Yeah, I mean, I'm just thinking from the library author, like you have your API, your create or something, and you return some opaque errors to the user. What are the use cases? I'm just trying to understand real use cases.
I've never done that. I've never used opaque. Opaque is opaque where we're using box of din error. Is that the opaque?
Yeah, like without any concrete type to the public API. So they have no idea what concrete type is.
No, and you do see that. It's like this error does support the enumerations, and anyhow supports the opaque type, right? And you never see anyhow being used in the library. You always see this error, but you use anyhow in code that consumes errors, that receives the errors from a library, so they can pass it around without, with convenience. You don't have to say this was a foo error. You can just you can just get that foo error from a library call and then use a question mark and push it up to a result of an anyhow result.
Yeah, basically you don't have to worry about all the from and conversion traits, right? Yeah. Yeah, interesting. Yeah, I mean, when I read this example also, image decoding library, I mean, I also couldn't think of any real example for the opaque errors. But the one conversing point for me, at least, like when you're dealing with some kind of in-memory data where you don't have control of, and then it's completely like compression algorithm or like some kind of binary data you're dealing with, that's encoding.
I think like maybe the most simple example is when you have like a command line interface with Clef, and you just have an interactive CLI running this in the loop, and you can then work up with an opaque error type.
I can think of one use case is when you have a function that tries many different things inside it, and you're going to have different errors types. So you'll open a file here, you'll set up a window here, and so you could have a window error, or you can have an IO error, or and multiple, right? And you don't want to convert them into a single error type. You can just return an opaque type at that point, right? You can return a box of din error, and so the window error will get returned, but but all the error, but you have to box them, right? You have to stick them on the heap before you turn them.
No, I think the opaque error can be a concrete type error, but it shouldn't be like enumeration. For example, it can be like simple my custom error with some like maybe with some line number inside it, but everything else is private field. It can be opaque error. That's opaque error. The only thing is, yeah, you don't provide an enum of errors, basically. So I think that's what here. Yeah, it can be a single concrete type with all the private fields, or can be like this box error.
Right.
Yeah.
I did just have a quick look. I just thought of an example library that might have one. So I had a little quick search of the Rocket code base, and it does have at least one example. I've only kind of had a quick look, which was for like bind errors. So it's got like IO, bind, and TLS. And the bind error, so it's an enum, but then within the bind case, it's got a box dynamic error inside it. So I haven't looked like where that came from or why it was needed. But I guess there's certain error types where it's like you've got enough information already, and concretifying everything below that is maybe not helpful. And it's maybe an uncommon use case, but I don't know the context of it, so I'd have to do some deeper digging. But it's worth search around your favorite libraries and see if they've got any box dynamic error types or any I guess it'd be harder to search for the concrete error type with private fields only exposing limited methods, but it probably could be done if you're very, very good.
Doesn't anyhow do that with the context call, where you can link to another error. So you create an anyhow
so that's
you call context, and then you link another error. So you have this chain of errors.
Yeah, but you're still ending up with probably essentially creating type raised errors there, right?
Yeah, because the anyhow supports any error.
Yeah, so you can have a search for anyhow and see if there's any use to that, but I imagine that'd be slightly less complicated. But yeah, awesome talk. Lots of good discussion after. I imagine we'll all be thinking about errors for a long time after. I will steal the screen share now just to talk about what's coming up.